Hey guys, I'm going to do a code review here of a reader's submission of the fountain of objects. This person's gotten through. So the way that's set up in the book is there's a base challenge, and then there's like 5 additional challenges. And I'm trying to remember the details, but it's like it gives you 2 options: either start with the base game, and I think do 2 expansions of your choice, or start with my code and do 5 expansions, do all 5, or maybe it's like 5 of 6 or something like that. So this person did this and had some complaints and then said, maybe I'll just forget this. Like, I don't like this and I don't like that. Maybe I'll just forget this and I'll just do, um, I'll just like do the other challenges using RV's solution. That could work. I will say that I plan on in future editions, I plan on removing the option. I'm going to simplify it, but I actually have always kind of disliked that there's this thing that says take your pick. Depending on what you pick, you get a different amount of XP. And I'm going to guess like 95% of all readers just do all of it. So I'm going to simplify it a little bit and then just expect people to do all of it. So some of this is maybe just a preview of like what I expect it to be like in the future. But the other thing is that I want to mention here is I actually think a lot of people, especially if this is the first time they've like really gotten into C sharp or like a serious study of programming and especially object oriented programming, I think that there's a lot of people in the same category as this person where they look at it and they're like, I'm having a hard time with this. I don't really like, I get the mechanics of like inheritance and interfaces. I just don't know when to use it. And I want to, so I want to explore this code for not long. I'm setting a timer for 20 minutes. We'll see if I stick to that because I think that this is, I think a lot of people feel this way when they're getting to like the fountain of objects, which is like the first big substantial boss battle that demand, like, I want to say this is probably the first time where it's like actually like with tic-tac-toe, you could do it without just fine. You could do it without objects, but this time starts to feel like, nah, this is starting to be big enough to justify it. Let's see how many lines. This person ended up with 258 lines of code. So you can start to justify it. So I'm talking to not just the person whose code this is, but to everybody who's been in that situation of, I have this code and I'm not sure what to do with it. And the main takeaway that I want to say is all I'm really asking for in these challenges is do it to the best of your ability. If you're getting in here and saying, but I don't like this, and I don't like that, and I feel like I might have misunderstood this thing, and I didn't like that, like, good, you're learning. You're learning what works and learning what doesn't. And you could read books about it, but the thing that will answer that question for you the most is literally just to do it a bunch and to analyze it and say, I don't like this about it, and then to try something different, like iterate on it and clean it up and do something different about it. So that's kind of what all I want to do here is just it basically kind of give this reader and other people who are like this some reassurance that, look, just because your object oriented design for this thing didn't work out like you had wanted it to, or you have complaints about it, doesn't make it invalid. Certainly, for the purposes of trying something out and learning, that's exactly what you're going for. But even without that, me, like in a professional setting, that's how I work. Like, I'll try out stuff and I'll be like, ooh, but I don't really like this about it anymore. Like, that my initial thought doesn't withstand everything that I'm throwing at it. So I'm going to change it. So that notion of just do something and then just plan on changing it is the heart of writing software. I'm going to make a couple of, so I'm going to just go through this and make some changes to it that might kind of point, um, that might point people down a path that might be useful if you're finding yourself in this situation. So first of all, I'm going to rename this to Fountain of Ob. Like, I had the underscores. That's not conventional. So I'm just doing. There's a couple of these that I'm renaming because like the convention um, is like that's for me, that's a good starting point is to follow the convention. So there's a few of these that I'm renaming. The convention for class, like for most, like it's either everything in C# is either upper camel case, which would be like that, or it's lower camel case. And the only difference, and by the way, this is, sometimes this is just called camel case, and this is called Pascal case. The only other, so and then every once in a while you have a few things that are underscore prefixed lower camel case, and the only other thing that's ever used in C# is like that with underscores, and that it like there's only one thing that uses it. It's not used very often. It's compilation symbols. So like you could do something like pound debug. That's the one time pound if debug, like these are those all caps. And so this is the only time you end up with mid-word underscores. Otherwise, the capitalization of the letter is what tells you you're starting a new word. So I'm just changing a few of these to like align with the convention. And let's see, were there more? I don't know there's more. I'm going to remove the parentheses here. That would give it a constructor, a parameter. This is the object, a primary constructor. The book actually hasn't talked about it, but it's in the C# 13 expansion. So like if you go get the expansions are all free. They're small compared to the book, but you can go get them on the website. See, that was probably more a mistake than anything. All right. You know what? I'm looking at this. I've seen a lot of people doing this. So, well, first of all, I'm going to use some white space here to align things a little better. Like this is also where you assign a value mid switch expression is not very typical. This works because an assignment is, so if I have int a equals 0, b equals 1, c equals 3. Okay. So if I do this and I like what I can do is I can say I don't know if that's Copilot or something else, but I feel like this is the kind of thing that's been happening a lot more lately. It's like, well, you probably want D, E, F, G, like, and like it's that's not the like there was no pattern. Okay, I'm complaining about the AI. Like this is just to make sure the compiler doesn't complain about unused variables. It like that, the comment is that, and it's still complaining about unused variables. Okay, forget that. Don't blindly trust the AI, kids. It can be helpful. It can be super helpful, but don't blindly trust it. Anyway, what I'm trying to do here is do something like this. Like an assignment is an expression. So I can say, so for example, I can say C equals 2 times 5, right? That's an expression. I can also do C equals B, but I can do C equals B equals 2 times 5. So this is evaluated by doing the multiplication, 10, and then assigning it to this. So there's the side effect. That's what programmers call it. It's this, like, besides evaluating the thing, what else happens? It's called a side effect, but in this case, that's like specifically the intent. So to call it a side effect feels a little misleading. Anyway, so this has a side effect of updating B, but then that same value 10 is then assigned to C. So an assignment is an expression. And aside from something like this where you're saying something like I want C and B to both be equal to something, that's not very common. It's actually super uncommon. So that's technically what's happening right here is this evaluates to something, but we have this side effect of updating difficulty along the way. We're updating difficulty right here. So we don't actually need this, and I'm just going to strip out all of these. and now the code is simpler. So I've seen a lot of people do that. Like I said, it compiles. It's probably not what you're looking for. Um, the other thing I want to do here, okay, this person, I won't do. I was gonna say there's a bunch of little things I might do. Like for example, I'll just say this. Like some of this, I might just make be the main method. Like I might move this out and make that the main method. Maybe it's worth doing. Like this right here. This is the game loop. This feels like. So here's what I'm gonna do. I'm gonna rename this to run, and then what I'm gonna do is I'm gonna take this while loop and stick it up here. So now my game loop is, sorry, yeah, okay. Now I should rename this to plain old, like that. Oh, I hate that it killed off my space there. So there's probably a couple of things I've lost here, and that is I've lost the player, I've lost the cavern. That's it. So what I can do is we will pass in the player and pass in the see, and again it generated that, but I don't, that's not very helpful to me. What I want to do is there should be create and assign field yes that, but I wanted to do that for now. I will say this, somewhere I've messed up my settings and I got it to like not do the underscore even though that's conventional. And I think oops, I think that had my settings been correct, I would like it would have just set it up this way. All right, so I pass in the player and the cavern, and so I had to do a little bit of work here to like get some input, and then I set up all my objects, and then I tell it to run. And this is a pretty typical thing. Like this could go into just its own method, but like this is a pretty typical setup. I often say that this is the Avengers Assemble method, and this slice of it, like most programs will have some thing. A lot of times it's the main method, which is what we've got here. Sometimes it's like another method that happens to do it, that it creates all the key objects and then like launches them. And I call that the Avengers Assemble method. That's what we've created here. But otherwise, objects, like very often this is typical. If an object needs to know about another object for a long period, like pass it in as a constructor parameter, save it off to a field so you got access to it later, and then you can use it. And that's a pretty typical thing. And the book talks about that. There's the object-oriented design chapter that talks about like how objects collaborate. There's a section in there that a lot of people, it's at the end of a very dense chapter, and a lot of people miss it. And I'm going to try to make that a little better in future editions, but it talks about this, but I've seen a lot of readers not connect the dots on it, and I think given it then the frequency, I think that's on me. I think that maybe it needs to be split into another chapter so people get like this like mental break, or maybe it's just like how to it's like called like how to collaborate or how objects collaborate or something like that, and maybe the title just doesn't like make it clear what the point is. So anyway, so I want to get to the heart of this this person's complaints, and their main complaint was this is adjacent method. Just it has a lot in here, And I agree, but again, like I don't. This is one of those places where I wouldn't say throw the baby out with the bathwater. Like, there is a lot of good stuff in here, and their concern was that they felt like everything was like hard coded, and that's not. It's not like they've checked all. Let's see, the largest map is what, 8 by 8. It's not like they've hard coded all 64. Like this could be so much worse. But so like this is the top left corner. Um, this is the um This is the left edge that isn't the top corner. This is the okay. Let's see. This is the top left corner. This is the top right corner. This is the top edge. And like I said, I this is not unreasonable. I'm trying to think like what could help here. But like I guess like I know what I've done in the past for this, and that is to just do something like this, where um like I'll just make like a private um it's suggesting all sorts of dumb stuff. Good times. Private, like something like this. Like we can do like int. So I'm just gonna use tuples, like list adjacent to like int row, int column. Right. So we're just gonna say like, give me all the things that are in here, um, and then we'll do something like this. We'll say return new int, and we'll do like row -1, column -1, row -1, column, row -1, column +1. And then essentially that again. So now we'll do row +1, +1. So we're just going to enumerate them all. They may not be on the board, but like we'll just get them all in there, and we don't need. And then this is like row that, and we're actually going to eliminate this one because that's ourselves. And something like this, like I said, this is one of those things like you see a pattern, you're like, ooh, I like that pattern, and then you use it yourself in the future. So it's a pattern that I've used in the past, and that I feel like solves this adjacency thing differently. So rather than like try and approach the whole thing all at once, let's break it into pieces. Let's start by saying, well, let's just, um, I don't know, give me all of them. So we'll do something like this. We'll say, all right, so we'll just say, just give me all of them. Uh, with that said, we definitely can simplify this. I'm going to do this. This is a C sharp, I don't know, 11, 12. The collection expression, I think, is a C sharp 13 feature. No, 12. I think it's whatever. This hasn't been covered in the book, but you can just do like, you know, you could do something like this where you just say, if you want like an int array, you could just do this one like that. Nice and simple. I love it. Obviously, with what we're doing here with tuples, it's a lot more complicated, but it's the same idea, just more complicated. So we'll just get them all, and then we'll do this. So private bool is on board, and then just say, well, if we'll just have a thing that just tells us. So if row is less than 0, return false. If row is greater than, what I'm going to do is if it's less greater than or equal to the length, return false. And then we need to do the same thing for the column. Change this to 1 and then return true. So if like we check it in each direction, and if we've fallen off the board in any of those directions, then it's not valid. So now what we can do here, say for each. For each if is on board, and then let's see what were we looking for here. So this is like, so if so basically all these things, like if it's that, so if it's on the board, hang on a second, that's my timer, that means I need to stop. If it's on the board, then we can go ahead and check. So if cavern rooms at location.row, location.column, grid type equals grid type. Okay, in this case, it actually, like that, the code that generated is fine. Other than what I would actually do is I would say, if we found it, let's just return true. So otherwise, if we get through the full set of candidates, filtering out the ones that are like skipping over the ones that aren't on the board, and then yeah, so if we get through all these and don't find it, then we return false. So we actually can get rid of this is adjacent. I think, like I said, I think like I like this version of it now that I'm seeing it this way. Like we can, don't need this, don't need this, don't need this. Some people don't like having that much nested stuff. You like, there's a lot of little things we could do here. Like I said, if you like the curly braces, keep them. We could do if is on board and that, like we could do that. We could just unpack this. Like we could just do, let's see, if I just do that and then I don't do this, it will do tuple deconstruction, and then I can just, like, it just unpacks it into the two variables. And I kind of like that better. We could make a record type for that. Like I honestly think that would make sense. Like we're using it pretty heavily here, but to just do something like public record location and row and column, like that, like that's, and now make this list adjacent just return an array of locations instead of an array of tuples. Anyway, like there's a lot of little things that you could do if you wanted, but so this approach now like breaks that out into two other methods. One that just says, I don't care if they're on the board or not, just tell me what's out there, and then I'll filter it out after this. Like I know I can check that first, and then this code down here got simpler. But the other thing I'll say is, like, sure, that was kind of brute force, but I like, there's a lot there, but it was also well contained in a method. So you don't have to be, you're not forced to deal with that complexity most of the time. The only time you're forced to deal with that complexity is if you're in that code trying to modify it, or wondering if you need to modify it. And so, like, I like, personally, I like this version better. I think it's easier to think about. And I also think that something like this right here could be reused. maybe this could be reused. Like I think there's room here for things to be reusable. It breaks it down. Like it's definitely less code. There's a lot to be said about that. But I really like the main thing is sure what was here before was complicated, but it's already abstracted. It's put into this method, and unless I need to change that, I don't have to deal with that complexity. So I actually think that what was here was fine. I'm not all that concerned with it, and I also think that that was a good mental exercise to think through. Like I've got like what about this situation and what about that situation, and to just kind of work through all that. I think was worth the time, worth the trouble. So if that's like if your code ended up that way, where it's kind of this like, what about this? What about this? What about this? I I don't I now that we have this version, I prefer to keep it this way instead of reverting back to what we had. But the other version was like it was within reason. So again, it could have been a lot worse. What we had is probably a bit more along the lines of like with the tic tac toe problem to do something like check that the top left, the middle, the top middle, the top right, and then like to check the middle left, middle center, and then like middle right. And to like do these kind of more hard coded checks. Like, could we have used like a loop to do it? Sure, but that's like my tic tac toe solution. It is that way. I just rather than try and come up with the loops, I just did something simpler. So I don't like the code that was here for is adjacent. I think was totally reasonable. And then in terms of like object oriented design, oh, I'm going to rename this. I'm actually going to like I the conventional name for this should be that. I'm going to just simplify it to fountain because we have a class that's called fountain of objects. Um, but so like otherwise, honestly, I'm generally pretty happy with what's here. I think there's room for like out of everything else that's going on here, the only thing from an object oriented design perspective, the only thing I hesitate on is I feel like we made a player and derived from grid square. And I, that's the thing that feels weird to me is I don't in my brain. So it depends. Like again, it's useful to align the code with the mental model that you have of things. If the player is like just another type of room, or grid square like that, this doesn't call it a room. The code I had a room. Um, but so if in your head a player is just a special type of a one of the many flavors of grid squares, that's when you use inheritance. So inheritance is it's a pretty strong relationship that makes sense when it makes sense when one type is just a specialization or like a specific flavor or subtype of the other thing. In my brain, I don't think that a player is a grid square. Like it's a different thing. Partly because the rest of these things, fountain, entrance, pit, empty, they don't move around. The player does. And so in some ways, if I do it differently, I like for example today, like these are settable, but I don't necessarily need to make these settable other than to account for the player being able to move around. So if I separate out the player into its own thing, then I think that simplifies things. So I think that maybe be the one other thing I do. And I think the reason why a lot of people in these cases will like derive from say grid square um, is because they know like it's got a row and a column. Inheritance does allow you to reuse code, but you don't want to like just because you want to reuse the code doesn't mean you should use inheritance. Like if code reuse is the only reason you're doing inheritance, that's not a good enough reason. You want to use inheritance when the thing is a special type of the other thing. Especially there's this principle called the Liskov substitution principle, and the concept there is if you because you can do something like let's see, because you can do something like grid square grid square equals new player, right? Like because you can do that, nobody should be surprised when and like so I can do this, but it's also possible that I don't even like see this. It's like calling some method that returns a grid square and that happens to return a player. I should not there should be no surprises when the thing that I'm actually modifying here is a player. Right? That shouldn't be surprising to anybody that the derived types should be fully substitutable for the base type. And that's a pretty strong assertion, a pretty strong relationship. And I would so yeah, my point is I think the reason, and a lot of people do, and it isn't just beginners. There are a lot of very experienced developers who will say, well, I want to like my player also has a row and column, and I've already defined a thing that has a row and column. So what if I just make the player derived from grid square? But I would honestly, in this case, like I would just where's my player? There it is. I would just not do that, and I would do that. And then I don't need to assign the grid type to player. And I don't think this is going to break too much stuff. I can actually remove this from that enumeration. And I think everything else compiles with how we've done that. Yeah, I'm not seeing any red here. So I think we're good. Like if you, and the other part of that is if somebody said, but I don't like, also now actually, the other thing I was wondering about is now that I've done that, do I actually set find no references? I don't know that these setters are going to be, oh, okay. So we are initializing the row and column here. Like so the next question I've got is do we need it? Let's suppose we deleted that. Does anybody like who care like and the reason I say that is like we know the row and column of any given square if we're coming from above, if we're coming from the cavern grid, right? We in order to even look up the grid square, we had to know about the row and column. So does the do we have to be able to know that going the other direction? If we know about a grid square, do we have to be able to like figure out where it's at? The way the code is written today, it doesn't look like it doesn't it doesn't look like that's the case. So like now grid square just it's just this. In fact, being honest, there's I like now that this is just a wrapper around this, I kind of wonder if we go up to here and make this just be whatever that enumeration was. I okay. With that said, I actually think that it could make sense to like this makes sense as a concept. This represents the whole room. This just happens to be a type. I think in my code I had derived types for these, like the fountain was a derived type, and the reason I might do that here is let's see if I can find it. It's some of this stuff like um this like I actually wouldn't so this is just part of like the map like so in my mind this cavern grid is the entire like map, which I think is fine, but I kind of like so player dead, player fountain, that's whether the player's in the fountain room. Like this stuff works, but so imagine, and we don't need this, but imagine if you had multiple fountains and you had to go activate all of them. You had to go find all of the fountains in the entire map and like that's how you'd know. That's so it wasn't just turn on a fountain, but turn on all of them. Now that data clearly, like, it's there's multiple fountains, and each of them has their own state. So at that point, it makes sense to have an object for that. And so like that's the moment where I would say, okay, we definitely want to make, and maybe in addition to, or maybe instead of, like this. So now when we have a fountain, we can just do that. And somewhere in here, there was a, I don't know where this gets set up. This right here. So like in this case, you'd need to do something a little more like equals new, create a new fountain. Something more like that. Um, but now now this, like, I can remove this fountain on and just check the fountain itself. Now that's, again, we don't need to do that here. Okay, it does complicate things. Like here, we'd have to like find the fountain, or maybe we'd want to like maintain an array or a list of the fountains in the map, or I don't, anyway. I think it's fine. But that would be a reason you might consider having derived types, is if they need their own unique data. And I think fountain does. I think you can make an argument that fountain does. But we don't, like, the way this person solved that. I'm not like, I'm fine with it. So I think it works. I think it works well enough for where they're at in the, where they've gone through a couple of challenges, but I also think it's probably good enough for getting through all of the expansions. Anyway, the point is like, sometimes, like I said, don't go, like, the effort to go through this stuff is really how you start to learn why, like, design choice was a good one and why something was a bad one. Like, this is a learning opportunity. So even if you're in here looking at it saying, man, I didn't like my objects, I didn't know that I should have used inheritance, like, a this is how you get that experience. You just do it, and then you look back and say, I didn't like that. And then you think about, like, what was so bad about that, and how do I get it right next time. This is how you collect that experience, the true experience points that allow you to actually grow, so that the next time you're sitting here solving a similar problem, you have, reference points to look back on and say, I did that last time and I remember not liking it, so maybe I'll try something different this time. The other thing is, again, like, to say, you get in here to a certain point, you say, I wish I had done it differently. Well, the numbers that I use, and this is completely made up, but based in reality, 90% of your time you'll spend reading existing code, not writing code. And out of the time that you spend writing code, 90% of the time you'll be modifying existing code rather than writing new stuff. Which means only 1% of the time are you doing like green fields, clean development with no strings attached. So the idea of writing code that's understandable, easy to make sense of because you spend a lot of time reading it, is extremely valuable. And then working in existing code, this idea of like taking code and changing it. The point of software is that it's soft, that you can change it. That matters. So, like, if you get in here and you're like, but I don't like my code. Like, if this was your code, if your code was like this, you're in great shape. Could things be different? Sure. If I went and looked at my solution, there's probably things about it that I would have done, that I'd do differently. Like, you get experience anyway. Yeah, like, I could always find little things that I'd say, yeah, we could change that. You will too. The point being, like, don't worry too much about that. Do these to the best of your ability. When you find issues, you're like, man, I wish that were different. Like, that's an opportunity. Change it. Get in there and get some practice refactoring, because that is a really valuable skill. Is to be able to, like, look at what you've got, think about what you might prefer it to be instead, and then just give it a try and see if you can change it in little steps and just turn it into something that you like. So whether it's this method that is like that is adjacent, which we did, or like some of that refactoring to like make the player not a grid square, like whatever it is, or to like introduce a fountain like subclass, like whatever it is that you're sitting there saying, maybe it should be this instead. You're not, like, the code is not locked in stone. You can change it. So take advantage of it when you think of those things and say, man, I wish this were different. Um, with that said, sometimes looking at somebody else's code and seeing how they did it, and even like working with it, which is the person who did this had thought, well, maybe I'll go do the other expansions using RB's existing code, which is one of the paths that the book says you can do. Sometimes seeing how somebody else did it gives you a lot of insight into options. Sometimes, especially if you're sitting there saying, I just don't know how to solve this. All the ideas I have feel really dumb, and I don't even know where to begin. Sometimes seeing a solution, any solution, starts to get your brain going with, oh, yeah, I see how they did that. And this thing, I kind of like that. I don't like this other thing. And so that when you go do a similar problem in the future, now you have this like mental library of things that you've seen, maybe things you've experienced, maybe things that you have written yourself, and a lot of information about how well it worked or why it worked. And as you write software, that library of knowledge will only grow. So, all right, I spent way too much time on this. I, I I meant to do 20 minutes and it's been 40, so yay. Hopefully that's useful to the person who submitted this code for um, feedback, and maybe hopefully it helps other people as well, because like I said, this is the same type of stuff that everybody asks about. So all right, I guess I'll see you guys around next time.